Hello and welcome to Fresh Thinking by Snowden Optiro. My name's Tarrant Elkington, General Manager, and today I'm joined by Hamish Guthrie, who's the Managing Consultant for our mining team here in Perth. Hamish has more than 25 years of operating and consulting experience, covering a range of different mining methods and commodities. Welcome again to the podcast.
Thanks, Tarrant.
The topic for our podcast today is model preparation process, and that's part of a series of podcasts talking about the open pit mine planning process. So if you want to catch up on previous ones, please go back and have a look at our podcasts on those. But to start this discussion on the model preparation process, maybe we can just start with what a mining model is, Hamish.
Yeah, so a mining model is a 3D block model to take the resource model and then add modifying factors and other elements suitable so that we can start pit optimizations and mine planning with it.
And what is involved in creating a mining model?
And it can vary from the different complexity of the geology, but typically we're trying to simulate what the material is going to look like as we send it to a processing stream. So it may include adding dilution and ore loss, knowing that as the material is mined, it's not taken from the perfect in situ resource model as is. It's been changed. It may include adding more waste or more backfill or other on-ground elements that aren't ore related, that may not be in the resource model already. So it's to get that 3D representation of everything that's on the ground or in the ground that needs to be considered in a pit optimization or mine planning process. We may need to add groups or new fields into the model so that we can assess the different costs or different recoveries or the different treatment of materials. We may need other groups to highlight different confidence material in a model. All these things will depend on the different processes that we apply in the next step of pit optimizations and mine planning.
So we're really just trying to make something fit for purpose, right? For a mining engineer, we've got different purposes, right? The resource model is done for a different reason necessarily than just to serve, generating the mine plan. We're trying to estimate what's in the ground. So it's about connecting that gap between what's in the ground and ultimately what we're trying to forecast.
Definitely.
Going forward, right?
So Tarrant, why do we need a mining model?
Well, I don't think you really need a mining model, and some people just try and grab a resource model and run it through a mine plan and apply all the other option is to apply all these factors within various pieces of software, right, to reflect the things that you're trying to put in. Personally, I like to create this mining model. It's something that I think it's good housekeeping, and it helps us to store in one place all this information, spatial information that impacts on our forecasts, and it's able to be audited by somebody else. They could pick up that model and understand and report it and be able to replicate the numbers that you're getting, rather than have to go into numerous pieces of software to find all of the assumptions that you've put in. So I think that I think that they're sort of the two key things that I think why I personally think is a very important part of the process. Maybe we could now go on to talk about some of these modifications that we're making to our resource model to create a mining model, with the big one being dilution and ore loss in our mining model. So I guess we'll start with a basic definition of what dilution and ore loss is.
Yeah, definitely. So the definition of dilution is any waste rock that sits surrounding an ore block will be included with the ore. So when we look at grades for material, they will be impacted by this additional material, which will be inherent with the mining method. A large excavator with a large bucket, if it's mining through a narrow ore seam, is likely to carry more material. The other factor is ore recovery. This being any material that sits in that resource model, if that doesn't find its way to the mill, is all lost. So that needs to be factored in into a mine plan as well.
Yeah, I think it's important to everybody to appreciate that we can't just extract the resource as it is. I mean, we try to, we'd love to, but it's not always possible. And even if it was possible, it's not always economic, to be able to mine that selectively.
To grab every last block.
Absolutely.
I agree.
So it's reflecting that imperfection, right, of the mining process. How you typically incorporate this dilution and ore loss into a mining model?
And there's a few different ways. Quite simply, if you've got quite a consistent ore body, maybe factors are quite appropriate to show that your material is going to be diluted by a certain percentage and your ore recovery is going to be applied. For more complex ore bodies, especially ones that change in width, then other methods, and this might mean where we regularize the block size through a model, or we apply a dilution skin around a model, both a couple of other methods of simulating dilution and ore loss.
Because we're trying to take a physical process, and apply it to something that is in a computer and cubes, so there's no perfect way of being able to do that.
And still trying to automate it as well. In the perfect world, we could manually draw out every dig block, but we don't have time to do that. So we need computer processes or factors to do that work for us.
I think sometimes it's people who don't do the process, they sort of think, the ore body's one homogeneous thing. It's this thickness, it's this, they look at the averages and in reality they're very different, often in deposits all over the place. So dilution and ore loss is something that's impacted spatially is a very important consideration. I think to also come back to one of your points there with the factors, reconciliation is a big part of that, right? So if you have an operating mine and you understand how a resource model goes to a mining model, if you're measuring this, then you can obviously make very scientific decisions. The hard bit is when we don't have reconciliation, we've got a new mine and we're trying to figure out what's going to happen when it doesn't always happen the same way in every, convert the same way in each mine.
No, I agree. Operational mines where you've got a wealth of data where when you're provided a resource model and what it's going to turn like out of the ground from the operation, provides a wealth of information, not just in terms of total figures, but also over time, which can be very important to shorter term schedules. And agree that when we're looking at greenfield projects, you don't have that wealth of information. So we need to come up with similar examples, and maybe based on past projects or the complexities of the geometry of the ore itself.
So maybe what are some of the other factors that are involved in making this decision between which, like if we've got lots of methods that we could apply, which are the factors that we would incorporate into making that decision about what we do in a particular case?
And sometimes it is some analysis needs to be done. initially, factors are the easiest one to apply, but some analysis needs to be applied to the model in terms of sections. Is there a huge range of different ore widths that over time we could get this wrong if we use factors? In terms of the other approaches, we may need to run them a couple of times to see, is that providing realistic outputs that we expect from this style of deposit in terms of dilution or loss or recovery values.
Yeah, I mean, in my experience, where the things that are going through your head, like obviously factors can be applied on a global basis, or they can be applied locally. You can apply whatever logic you like. The big discriminator is whether it's a bulk ore body or whether it's narrow ore body. If it's a bulk ore body, then typically reblocking is the most common form of method that you would use. If it's narrow, then you would use some sort of a skin dilution which just reflects on the edges. Either way, none of those methods are perfect, but the reblocking and the skin dilution basically allow you to penalise the edges of the ore body. And that's typically where this dilution is taking place. So we're really trying to mimic what is going on in reality, but it's not perfect.
Yep. And also trying to incorporate the style of mining. If we have a small excavator or a lot of selectivity in the mining method, then maybe that skin dilution doesn't need to be as great. But if you're using some of the larger iron ore fleet, then a more realistic dilution will need to incorporate those larger dig buckets and etc.
And I think when we're trying to determine those things, we're looking at the sensitivities, right? So that's there is, unless we've got reconciliation, there's no perfect way of doing it. So we need to test the sensitivity of doing it that way or that way, and how sensitive the tons and grade are, because that dilution can make a huge difference to the value of a project at the end.
Yeah, definitely.
So if we move on from dilution and ore loss application, maybe we could talk a bit about some of the other things that we add to the model that maybe the resource geologist hasn't put into the model.
Yes, good point. A lot of mine planning encompasses different material types. So these can be very important as they go through a processing stream. They may have different recoveries that we need to apply. They may have different costs. There may be material types due to their hardness or their softness, which makes them more costly to mine. So all these things, if we can break them down and group them into the mining model, then we can treat them differently into the pit optimization. So that's where they become very useful.
Some of the other things you might think about, like waste, we talk about ore characterization, so different weathering types or lithologies or geometallurgical domains. But on the waste side, we've got things like acid forming material. So we need to know how much, if we've got that issue, we need to know where it is and what time that it's coming out of in the mine plan. Some of the other things that I would probably add, geotechnical information. So the slopes, that we are able to use often vary spatially. So we can code those zones into the model based on work a geotechnical engineer has done. Lease boundaries and exclusion zones, heritage areas that we might not want to put the mine plan, then we might code those onto the model. And also, depending on the horizon or whatnot, we might want to code on some things like mining productivity factors, how truck hours, digger hours, milling hours, even for the equipment to reflect the various productivities that we might get that are different for each block. So some of the other things, and obviously we've gone through a range of different things that you do to modify a resource model to a mining model. But some of the things we do is simply to make the model more efficient to use, because that's what we're trying to do is processes that can take some time. So what are some of the things that we do once we get a resource model, maybe to clean it up or to change it to make it more efficient for us?
Yeah, so as you said, Tarrant, the model size influences runtimes. Some of these pit optimizations can go for hours, days, and longer. And if we want to run multiple scenarios, that influences the information that we can get out. So we may be deleting fields, we may be reducing some of the size of the model, but generally just having an understanding of what fields do we need and for the pit optimization and which ones can we leave behind.
Yeah, I mean, somebody doing a resource estimation, often for that purpose, adds in certain fields, Kriging variance. I'm not a geologist. I think I've declared that before on the podcast, but so forgive me if I get the terms wrong. But some of these things are actually not that useful for us. Yes, useful for resource geologists, but not for us. So we kind of drop those things from the model, because if we can make it smaller, then all of these processes run faster and we can turn more things over. And I think maybe we just finish with just a reflection on like we are converting a resource model to a mining model, and that takes a period of time. And so when you think about what a resource, maybe there's a message that we can give as we cross our silo between a geologist and a mining engineer about what a resource geologist should think about if they're trying to help deliver a model that is easier to use in a mining context.
And sometimes it's just that conversation, Tarrant, is to sit down with the geologist to...
Controversial. Yeah.
to talk through what the real needs are of the project. And it might be simple things. It's the open pit is likely to have a crest outside of the model boundaries. Getting some of the geology information from the waste rock, which may not be their interest at the time, makes our life a lot easier. It's also some of the block sizes and the other details. A lot of resolution goes into the ore. Our processes normally mean that we might deal with bigger blocks, so we can have those conversations and work through what really matters when we start building up our mining model and then go into the pit optimization.
And I think there's been a process of late, I guess, or a trend of late, where you have localization of models, what they call localization, where so rather than have a percentage in a block of ore, they try to attribute it to a spatial location. And the one thing that I would say is the models that have a percentage in them, they are difficult for a mining engineer to assess dilution and ore loss, because they can't see exactly where the bottle is. There's a block that has a percentage of ore in it, but you can't see where that's located. It makes it very difficult for a mining engineer to make that educated assessment on that basis. But I think you make a really good point, and I think it would come through in the whole spectrum of things we talk about when you actually sit down and talk to somebody, stakeholders in what you are getting and what you are delivering, then that will always enrich the process and what you're trying to get out of it. So, for when somebody's doing the resource model, just to talk to the mining engineer about what they're looking to do with it actually makes the whole process better. The handover of the baton, it's cleaner. So I think that's a great point. So I think that draws our podcast to a close. Hamish, thanks for joining us again on a Fresh Thinking podcast and participating in this discussion about mining model preparation for open pits.
Thanks, Tarrant.
If you'd like to listen to more of Fresh Thinking by Snowden Optiro podcasts, you can find us on Spotify, Apple Podcasts, Google Podcasts, our website, snowdenoptiro.com, YouTube, and any other podcast platforms. If you enjoyed the podcast, please subscribe to our YouTube channel so we can keep you up to date with our next technical podcasts. And please stay tuned for the follow-up in this series.